Welcome to ClickMyProject.com.
Now we are going to discuss about the product hiding data using efficient combination of RSA cryptography and compression steganographic techniques. Now we are going to discuss about the abstract of the process. Image compression and encryption is an important part of information security because the compressed data is more secure than the normal images, and then it is easy to handle the data with less number of sizes. That is, the capacity of the data will be the low, hence it is very easy to handle. Hence the effective data compression technology creates efficient, secure and then easy to connect the data with others. In general, there are two types of compression technology is there. One is the lossy compression and then the another one is the lossless compressions. Hence the lossy compression having the data losses and then the lossless compression does not having any kind of data losses. These technologies can be used in any data format such as the text, audio, video or images. Hence in this process we are using the image file to encrypt the data as well as the compress the data. Hence, to improve the security by means of the encrypting this data and then hiding it from intruders by using the LSB algorithm. The LSB algorithm secure the data, hence the DWT algorithm compress the data. Hence the reverse process is done in the decryption size. Then finally the performance will be evaluated by means of the performance parameters like PSNR, that is the peak signal to noise ratio, MSE, that is the mean square error, then the correlation. By using these parameters we can justify our process is efficient or not. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. This is the modules consist in this project. The first one is the input image, pre-processing, compression as well as the encryption, decryption, decompression as well as the decryption, then reconstructing the image, finally the performance. So this is the module wise. As per this module wise only we have designed the project. At first, the input image is taken from the dataset. The dataset consists of lot of RGB images, that is the color images. After that we just get into the pre-processing. One of the pre-processing is the wavelet, hence the wavelet is applied here. After that the third step is the compression as well as the encryption. First of all we just see the compression methods, hence the DWT is used for the compression. DWT is nothing but the discrete wavelet transform. By using this discrete wavelet transform we are using the which type of transform is the hard type of wavelet transform. So by using that there are four kinds of the output will be there. One is low frequency, then the second one is the low high frequency, then the third one is the high low frequency, then final one is the high frequency. Based on these combinations the output will be there. Among that we have just took the low frequency for the encryption. So in this encryption part we are using the LSB algorithm to encrypt the image data. Before that we have to generate the key, that is the keygen. So the keygen will be generated automatically as well as the user can give the private key. So hence in this key the user can enter the data like the numerical data. After that the encryption will be carried out. Once the encryption was completed, the receiver side will be get into the by using the first step is the decompression as well as the decryption. So before going to the decompression we just discuss about the decryption. So in this decryption part the inverse process of the LSB is applied to decrypt the image into an original form. After that it will be reconstructed by means of the DWT, that is the inverse DWT. So after that the reconstructed image will be in the form of original image data. So finally the performance will be evaluated by means of the PSNR, MSE and compression ratios. Now we are going to discuss about the initial running procedure of the process. At first open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Now the initial GUI was open. In that GUI you can see the several push buttons in the right side for the controlling purpose, as well as the several axes in the left side for displaying purpose. At first click the button input image. Once the button is clicked, we have to open the dataset, and then you have to select any one image from the dataset. Once the dataset was selected, the selected image is shown in the axis 1 with the title original image. After getting the original image from the dataset, we just move on to the next step, that is the pre-processing. So in this pre-processing step, the wavelet is applied for the original image. Hence this is the image which represents the low frequency, then this is the image which represents the low high frequency, this is the image which represents the high low frequency, and final one is the high frequency. After decomposing the image into a wavelet transform, we just move on to the third step, that is the compression. So in this compression, the compressed image is shown like this. Once the compression was done, we have to go for the encryption process. So in this encryption process, first of all we have to click the key values like this. Once the key is entered, the encryption was done. So then we have to save the file in a separate manner. Once the file is saved in a separate folder, then it will be shown in the axis 3 with the title of encrypted image. Once the encryption was done, we just move on to the next step, that is the decompression. So in this decompression step, again we have to give the correct key. After that, we just extract the image from the folder, then the corresponding input will be shown here, and then the decrypted image is shown here. Once the decryption is completed, we just move on to the final stage of the process, that is the decompression. So in this decompression process, the decrypted image is again decompressed into an original form, that is the reconstruction. Then finally we just move on to the performance estimations. So once the button was clicked, performance like PSNR and MSE was estimated. Hence this is plotted in this bar chart. After that, this value is shown in this table. PSNR is 68.1%, MSE is 0.01%, then CC is 0.008%.